All right, hey folks, I wanted to talk about a GONet feature that is available to you to extend GONet as of v1.1.1, and it's about value blending. So whenever a non-owner machine receives values from the owner, it's going to be at a frequency that's not every frame, and you're going to have to blend between the values you do receive over time. You blend every frame so that it looks smooth on the screen as if you received all the values. So just to kind of give you a visual representation of what we're talking about here, based on over time, the values are moving. Let's say that there's a ball, kind of like the rollerball tutorial, that's moving, and this is just a simplified way to look at just one of the values that make a position. So at position 0 that we received from the owner at this time, that's where the ball was. Then position 2 sometime later, that's where it was. Position 0, 1, and then position 2, it's here at that time, this many frames down the line. So you can see that when this frame goes on the client, so let's say this is the server's representation, the server data that we received. So the client, every one of these frames has to figure out where to place the ball on the screen so that everything looks smooth. So that's what value blending is. We're blending between these two values that we know at times in between whatever time that occurred, whatever time that occurred, and whatever time that occurred. So value blending is figuring out, where it's supposed to be. So there's a couple of different things that you could probably think about here. You could do interpolation between these two. That's a technique that we'll talk about and we'll go over. You could, but here's the deal: is that 1, 2, 3 values that we receive. What if the time is somewhere out here, and we want to figure out where that is? That's going to be something that we probably need to extrapolate. So these are known values. You can interpolate between known values, but when you want to kind of predict out in the future, you're extrapolating based on this historic information where it is. So that's just to kind of give you an idea of what we're talking about. We're trying to figure out how to blend these two between these two known values at a specific time, so that frame on a non-owner can be rendered out and everything looks smooth. So let's go into the rollerball tutorial. So you've hopefully already been through this. I'm going to select the player, and it's got a GONet participant on it, and the position is the thing that we're going to be worried about here. So I can select this profile, and now it's going to select in the inspector this guy over here. This is our profile for the position, and you can see that we have value blending overrides, and what we have selected for vector 3, which a position would be, it's going to use this GONet plugin API, GONet default value blending. Okay, so that's what's going to be used out of the box. And if this was removed, it would still end up using this default setting, this default implementation. Even if I took that down to 0, the code will know to default to our default stuff if nothing's provided. So let's go ahead and just run and show you what that looks like right now. All right, so I'll start the server. I should make that a little bit smaller. All right, so whatever. There's a server. Alt-P, that spawns his ball. I'm going to start the client, maybe make him a little bit smaller. And he should see the other guy. That's great. So now I can Alt-P one in for him. And now you can see we're networked. You've done this tutorial before, but I just wanted you to see, like if you're looking, so I'm controlling this window here. So let's look at how, it's not as smooth over here, and when I hit the wall, it like does some wibbly wobbly stuff. But the reason this is happening is because of the value blending. So I wanted to show you what it looked like first, and then we can come back into that here in a minute. So if we wanted to change that, what we would need to do is create our own version of this that we could select. And then that's what will be used. So that's what we'll do. We'll jump into the code. So whenever you want to do that, there is inside of GONet code a plugin API. It's supposed to help us figure out and identify the areas where you can kind of extend GONet and make your own stuff. And that's what we're going to do. So this GONet Automagical Sync Custom Value Blending Interface. So I'm going to copy that, and then I'm just going to I'm going to make a new class. We'll just go somewhere into we don't even have it. Yeah, we do. Yeah, we have scripts. Well, that's under completed game. Yeah, whatever. We'll just put it there. So we'll go scripts, create script. We're going to call it testing value blending. Okay, so let's open that guy up, and let's make it implement from this guy, and we'll do that. So this is not going to be any kind of. So you can hit Control Dot and implement interface, and that will give you, boom, like some default implementation stuff here. So for this guy, we want to indicate that it applies to a vector 3. Actually, I'm sorry, it needs to return this type, right? It's not going to return a Unity vector 3. It's going to return a GONet value type that represents the vector 3 to GONet. So that's just communicating to the world that this guy, which I probably should rename so that it has vector 3 in it, but I'm just going to leave it alone for now. And a description. I'll just put something in here. See how value blending works. Yeah, something like that, whatever. Okay, so that's going to be there. It'll probably show up in the editor when we make these selections, so that you know what you're selecting and why, like what's specific about this particular implementation of this interface and why would I use it. All right, so here's where you really get into the territory I want to talk about. We want to explain value blending. How do you do it? What does it look like when you do it a different way? So in order to do value blending, you're passed in this kind of minimal amount of information that you need in order to start doing your own implementation. So you're going to get a buffer of values. So if you remember back to what we had here, there's this, and this. There's 3 positions here. So in that case, that's what we're going to get. It's going to have those 3 positions in there. But due to the way we optimize memory usage in GONet, we needed to let you know how many of these values are actually populated, because this array might be 100 in length, but there's only 3 being used here because this array was used, reused, and it keeps being recycled for memory optimization purposes. So that's what this represents. How many items, what's the value count inside that buffer? Then this lets us know when we're going to be predicting. So where this question mark is, or where this question mark is, that's the time. That's the at elapsed ticks that we're going to be predicting at. Now that's where I think some people are going to get caught up, and that's why I wanted to explain this. So we're going to talk about what ticks are, and then this is what you actually have to return. So you set this, it's an out variable, so you have to set this in order, and you can see right here that the out parameter blended value must be assigned. And we also must return a true or false to let us know, and it's very much like any other C# stuff. For a dictionary, there's a try get value in a dictionary that returns a bool and has an out value here. So it's a similar kind of API if you're familiar with that. Dictionary is one good example of that. But let's try to figure out what we could do. What if we just, no matter what comes in, what if we don't want to look at it and we just want to say blended value equals new vector 3 0 0 0, and then we can say return true. Right? Hey, we did the thing. And the reason we can do this blended value, see, it's going to be, it's supposed to be of this type right here. It's a struct, it's a GONet struct. It's called GONet syncable value. And we're actually returning a unity vector 3. So how does that actually work? Well, I'm going to show you what it uses to do that. It's these implicit conversions from primitive values. So it's this guy right here that would be invoked. And this is a C# thing. It's an implicit operator. I'm not going to go into the depth on that, but this is the code that allows us to come over here and return a new vector 3, but it actually gets implicitly converted and turned into a GONet syncable value, and that's why you can set that there. So what we're doing here is we're saying no matter what the values are, no matter what you put here, what we're going to do is return 0. So it's not going to do any real value blending. It's going to be something that's horrendous. In fact, it's just going to be sitting at 0 0 0. So let's see that in action. So I'm going to come here. I guess it already did my compilation. So let's select player. We will open that prefab. And what we want to do is we want to select the position like we did. And so now we should have another option in here. It's vector 3 is what we want. So now, hey, there it is right there. It's not in a namespace. It's just test value blending. So that's what we're going to use. We're going to hit Alt-S. We're going to save that. Build settings. Build. Okay, so we'll get that change in there. We'll start using the new, yeah, there we go. Get that out of the way. Hurry up. Okay. Boom. Yeah, so let's do a server. P. Let's do a client. All right, so you can see it's just staying at 0 0 0. There is no value blending. He's supposed to be, so the server is sending out his values at a certain frequency, and I'll show you as a reminder what that is. And he's not doing the same stuff over here. And that is because we told it to do value blending and just return 0 0 0 no matter what. So where is 0 0 0 in this level anyway? There's the ground. The ground is at 0 0 0. So you can see 0 0 0 is actually the center, and that's exactly where the ball was. So we can try some other things. We can certainly do that. We can do something that's a little more intelligent, and that's where we're going to try to go figure out how to do this. So we want to know if, oh, by the way, so you should look at this, about the value buffer. It is in an order where the most recent value is most recent at the lowest index. So index 0 has the most recent value that has been sent. So in terms of this, I should probably reorder these because that is a little bit, it's not good for the example, because the order that this thing is stored is actually going to be, that's, I wanted a pencil. Yeah, so that's 0, that would be 1, and that would be 2, in fact, based on what we just read here in the documentation, and I know to be true as the author. So we could say, let's just do some sort of for loop, I guess. Less than the value count. Okay. So what we're going to do is we're going to say, let's go ahead and get that value out of the buffer at I. And I don't like using var, so I just type var because it gets me there faster, and then I control dot and then use the explicit type, and now I can see, okay, great. So now the way this API works is we're going to have to do a dot. We can check the elapsed ticks at change. So what that actually represents is what was the time, you know, what was this? What time does that actually map up to? What time does that actually map up to? What time does that actually map up to? In terms of ticks. Now that's where we're going to talk about what ticks are in just a second. But it's a unit of measure for time that is going to be a bit larger than you're probably used to dealing with, but it does give you that granularity that we're looking for sometimes. So value, elapsed tick at change. We want to say, well, let's just go with another implementation. We'll come look at that here in a little bit. We'll add that if statement in a little bit later. For now, let's just say, yeah, in fact, I want to show you a little bit simpler, something that's slightly a little more intelligent than doing the vector 3, 0, would be a value buffer of 0 numeric value. So what that's going to do is, no matter when on the time scale we're asking for, right? So if we're looking at this tick by, frame by frame by frame, and whatever number of elapsed ticks is representative of that frame, we're going to return the most recent value in the buffer. So it's not going to do any blending at all. It's just going to give us the most recent value. Always return the most recent value in buffer. Although what we could do, what we really need to do is we need to say if value count, value count is greater than 0, you can do that. Otherwise, then we have to, let's go back to our old way of doing it, which was really not going to do us much. I think we can do .0, can we? Yeah, so that's a little bit shorter. So this time what we're saying is, if there is empty, it's possible. You don't want to assume that it is full. So we have to say, hey, as long as there's 1 in there, then we're going to use it. And that's what we'll do. We'll go back. We will build this again. Okay. So build it out. We're going to go through a couple of these. I wanted to make sure that it's understood what's happening. Why is it doing what it's doing? Because I don't want value blending to be a mystery to you. Okay. So this time, what we should see is, instead of it staying, So remember, the server is here, and the server is controlling the ball, so he's obviously he's going to look correct. We're going to come over here to the client. Oh, well, that's going to show you a slight discrepancy there. That's okay. That's another story. But what you'll see is it's choppy. It actually looks like it's not too terrible. But it doesn't look great either. It's not smooth. It's choppy. If you look at the left versus the right, it's chopping around. And I guess what I should have done to prove that point just a little bit better was to show you another aspect of why would that look semi-smooth and instead of completely choppy like I said it was going to be. So let's take a look at the position. The position, it's using test value blending, but it's also sending the change frequency at 20 times a second. So what we could do to make it even more obvious is put it to 5. So 20 times a second, it's actually kind of smooth in and of its own right. So let's do 5 instead. So now only sending out at once every 5 seconds is going to allow us to see just how choppy this implementation is of just returning the newest, the most recent value, I should say. Did I build, buddy? Okay, I guess I'm not. All right, so that's going to build. We're going to see just how choppy it is. It's going to be even more so than the last one. And let's do it. All right, server, bang, bang. Boom. Up. Should have brought him back. Let's do a client. Bam. Okay. So I'm going to come back over here. Alt-P. That gives me my guy. Yeah, there we go. So that's 5 times a second. So there is no blending. It's just taking the most recent value in the buffer, and it's choppy McChops all the way through. Not cool. So that's really not what we're looking for. We want to be able to blend that value. So that's what we'll do. We'll create our own, hopefully quick implementation of what a real blending situation actually looks like. So what we're going to do is we'll say if value count greater than 1. So now we're going to say as long as there's 2, what we're going to try to do is blend between those 2 that we got. So let's see what that looks like. So this will actually be, we don't need a real for loop here, do we? Because this is going to be more like what the end result would look like in a true full-on implementation. But if you want to see what GONet does for its default, let's look at default value blending. For vector 3s, and we can say try get value. Okay, well, it's got some code in here, right? And we've got some experimental stuff down here too, but this right here is the code that it took, you know, to get what we actually have as our default value. We're not going to go that far, and we'll probably just keep it simpler just for this video. So we know there's more than 1 in there. So what we're going to do is we're going to take this guy. We're going to call it, what are we going to call it? We're going to call it latest value, and then we'll call it next latest value, and it'll be 1. So we know those 2 are actually going to be there because we know there's and we're going to do explicit, and what we end up doing is just doing a vector3.lerp. We're going to lerp between it, and we're going to lerp unclamped. The reason we're doing an unclamped, so if you look at this, it says it doesn't really tell you what the clamping means here. Generally speaking, when you do a lerp, that float t, it needs to be between 0 and 1. If it's outside of 0 and 1, then it's going to clamp it down to either 0 if it was less than 0 or 1 if it was greater than 1. So what that would end up doing is if I was lerping between this and this, what that means is, I should say it's between this one and this one. When you lerp between those two, what ends up happening is this is time t0 and this is t1. If I were to pass in t of 1.1, it would be out here somewhere. A t of negative 0.1 would be over here somewhere. But when he clamps it, it would clamp it to here, even if you put 0.1. It would clamp it to here if you put 1.1. So we want it unclamped because we don't know exactly where the elapsed ticks lies on this scale. So what we want to do is we want to start to the next latest, because remember, this is the latest, this is the next latest, and time goes in this direction, left to right. So we want to go from this P1 to P0, somewhere in between there. We want to blend between these two values. So let's do that, and we have to do dot unity engine underscore vector 3. That gets us something that unity vector3.lerp unclamped can actually work with. It gets us the vector 3, and we do the same thing here. And now we got to figure out what t is supposed to be. Lerp time, and that's probably the hardest part of this, is figuring out what the lerp time should be. And the way that we want to do the lerp time is we want to say overall time. We need to figure out where we are in between these two values. So we need to know how much time has passed in between these. So for time duration, time diff is latest value dot at. Oh, you know what? I can't use the latest value. I need just the latest at elapsed time minus this guy. So the latest time minus the next latest time is basically what we're doing. And that's going to give us ticks. So that's okay, because so this is, I should say, time diff in ticks. So you can remember that we're dealing with ticks here. Not seconds, not milliseconds, but ticks. So we take that, and that should be a long. Yep, it's a long. And now, so if I just wanted to show you real quick, if I wanted to say time diff in seconds, here's how I could do it. Time span, control dot, so I can use system dot from ticks, and we can pass in time diff in ticks. So now that gives us a time span. Then we can say total seconds. So that's a pretty neat API, although I guess that's going to be, those are doubles. Total seconds is a double. Whoops, or a double. Let's say we wanted to float, right? How would you do that? You just do your normal little cast. Okay, so that's how you get seconds. If you're more familiar with seconds, which a lot of people are, they're not really thinking in ticks. If you really needed to, just to kind of sanity check yourself, use this API. All right, so either way, lerp time, we're not going to deal in seconds. Lerp time, we're leaving in ticks because this is in ticks. We need to know, like, so lerp time, if we were right here, that'd be about 0.5, 50% between here and here. So we need to know where we are on this time scale. and we have to use this to figure it out. So now we know the diff between the latest and the next latest. Now we want to do the actual time that we're going to be predicting the value for, and we're going to subtract that from our first time as well. So now we know lerp time diff in ticks. And that's not a float, my apologies. That's going to be a long. So now, let's go back to lerp time. So how do we actually get lerp time? So lerp time would actually be the lerp time diff ticks divided by the time diff in ticks. And we'll convert that over to a float. Or let's just leave it in seconds, because like I said, people kind of like to think in seconds, right? People like to think in seconds, and they're floats. You're used to messing with floats, so we'll change this to a float. We'll call it lerp time diff in seconds equals the same kind of deal, right? And you don't want copy pasta stuff getting in your way. You actually want to use this. Bam. And now we've already used that. So now lerp time is seconds of lerp time diff divided by the actual time diff between the two values that we have. And this lerp is going to produce, so blended value equals bam. So let's see what this ends up looking like. So this basically just says, let's lerp between the last two values we got based on this time and the time in between these two guys. All right, cool. So let's go ahead and build that back out. Build that back out. And it's only being sent at 5 times a second, remember? And let's see what that ends up looking like. And I've never actually gone through this exact experiment before, and I'm hoping it turns out okay. That was the whole point, is that I actually know what I'm talking about, and it will demonstrate, and it will look, I mean, this isn't going to be the greatest implementation in the world, and I'm not going to talk a ton about why that is, but you can see there's some artifacts from us doing stuff that's not the best, but it also looks a lot smoother than it did, but there are some issues. That's because we're lerping using values that might not be the actual best values to use to get the most accurate representation. Okay, but as you can see, it's a lot smoother. It's got some issues. It's a bit smoother. All right, so there you have it. That's just us messing around. There's obviously ways to do this better. If you want to see what we did for the default one or our experimental one, just come in here. You can copy and paste this code over in here and do your own thing. And maybe there's better ways. That's exactly why we created this API, is so that you can have your own ability to go in, because there are use cases that require different implementations for things to look correct from a value blending, because you might be blending data values that have a very strange runtime profile. The values might be bouncing all over the place. It might not look like this. It might not be a ball rolling on the screen. It might be human body parts moving around. It could be, I don't know, explosions and stuff. It could be anything that your game wants it to be. It doesn't have to be stuff that's on the screen either. There's all sorts of things. These are just values being blended. It does not have to represent things displayed on a screen. And I'd like to talk more about some of that to give you some ideas of the power of GONet, because you can do so many things that might not seem immediately obvious to you. But for what we're talking about here, here's just some simple little implementations. We showed what it looks like when you're done, and it gives you kind of a basis for going in and trying out your own stuff. So go do that. I'd love to hear your comments about it, and hopefully that helps out. And I was thinking back on the beginning of the video and leading up to this last moment here where we just implemented something that uses the interpolation, vector3.lerp unclamped, and it still didn't look like what I thought it was going to look like. And I wanted to point out, bam, it came to my mind. I was messing around with this project earlier, and something that GONet allows you to do, I had made some changes to. And I just wanted to kind of point it out. On the GONet global context, the value blending buffer lead time milliseconds, which you can read down there what that's all about, but that's basically for the entire simulation for all of the stuff that GONet manages and sends data across. For the non-owners, there's going to be a buffer of this many milliseconds to allow enough information to come across so you can smoothly interpolate. I, for testing, had it down to 0 so that it's always extrapolating on the non-owners. So that extrapolation is not what we were expecting when we were over here coding this solution. And I have since come in here and I tried something else here that's a little bit better. But just looking at what we did a second ago here, this should have been looking a little bit better than what was happening, and the reason it wasn't as good is because it was down to 0. So and it's always extrapolating, so we didn't write any code to extrapolate in a very good way. So let's add a 100 milliseconds buffer in there so that we can actually have a good amount of values built up. And when we have those good amount of values built up, what we'll end up doing is creating a smoother interpolation. It's actually going to be interpolation instead of extrapolation, so that'll be good. So when you change that, you save, and you also need to rebuild, because the server and all the clients need to have that value baked in. So let's just do that real quick, and then we run through this one last time, and it should look a bit better than what we just had in that last run. So let's start the server. Bam, bam. Let's get this, move him over a little bit, right? Just get him over there. Okay, now we can play. And we'll make him a little bit bigger. Well, it's still not great, but you can see it is a bit better than it was, I think. It's still not the greatest implementation, but since I have gone in and done even yet another implementation on top of what we just did, I figure why not, since I'm not really satisfied with the way this looks yet anyway, and we're still just kind of experimenting around. Let's kill that, and open back up this code. And let me uncomment this, which I haven't tested yet, by the way. I'm all about just doing stuff here. So all the rest of this code that we just wrote a second ago isn't even going to be hit. So this looks a lot more like what you're going to find in our default implementation over here. It's not exactly like that, but it's somewhat similar to this one right here, where we're doing the lerp. We're going from the oldest to the newest, and we're decrementing. This is the normal case where we can apply interpolation. So what we're doing here is going to look a lot like what I was just messing around with over here, but I'm using the same kind of code structure that we use down here and the same variable names, so it should kind of map up more to this example that we've been living in. So that's what I did. I said, hey, we're going to enumerate backward from value count -1. which is going to be the oldest. So the first I that we get is going to be the oldest, and we're going to move up towards the newest. And as we do that, we're going to check. See, this is what we didn't do down here. We didn't do enough checking at each one of these values that we arrived at, and its elapsed tick at change versus the actual target of where we want to provide a blended value at this time set. So we're checking against that, and if that value is greater, we need to start at the oldest, or else if we did it from the newest to the oldest, this routine wouldn't work. It has to go from the oldest to the newest. And once we find one that is greater than the target time, we know we're in a good spot. If there are other values prior to this, then we can actually do the lerp. If there's not, then we're just going to say, use the oldest value we have, since there is nothing older from which to interpolate. So that's what that really means there. We don't have any previous values, but we know that the one that we just arrived at is older, is newer than where we are. But if we do have one that's older, now we're in a position, and I close that MS Paint. You'll have to remember back to the thing that I had there, but between 2 points. Now that's what this means. We've got a previous and we've got a current. The current is greater than that, and the value previous tick is going to be before that. So this right here is right in the middle of the two values that we're dealing with. So we're going to do that same exact thing that we did down here, and we're going to, and this time we're going to do a regular lerp. We're not going to do the unclamped, because we know that lerp time is going to be between 0 and 1. So now let's save that, come back here, and since this is occurring on the client side only, the non-owner is going to execute this. We don't need to build the server. We can just start the server, because we didn't change the hertz, the update frequency or anything. So now we should be able to run this guy, and I'm hoping, if I'm wrong, I'm just gonna be mad, but I'm hoping that it looks better. In fact, it looks worse. I'm not having a good day here for some reason. I'm just not having the greatest of days. Oh, we still have it at 5 times a second. I wonder if that's causing him to just be terrible. Well, I'm not satisfied. I'm not happy. What are we actually doing? We got him at 5 times a second. There's a build out there. He's using the value blending. I guess this requires some more debugging. I'm just not really satisfied with that one at all, and I don't understand what the hell is going on. Let's see. Bam, bam. Interesting. So it looks like, so I'm just verifying against what, whoops. Okay, well, to me that seems like we're doing the same thing. Let's build it, ship it, put it into production. Just go straight into production. No worries. All right. All right, let us see what we have. All right, bam. it does look better. I'm still not really loving it though, to be honest. It looks pretty good. And 5 times a second, you got to know, 5 times a second is it's a very low number. I mean, you're not going to have it at 5. I did that earlier for the example. And now I think we're in a state where this looks pretty good. And by the way this looks in the editor, it performs better in a build. So this actually looks pretty good. So at 20 Hertz, which is the normal rate, this implementation works pretty well. Now maybe we could go play around in the code. Let's do another client. We could go play around in the code and make it work much better for somebody who only wants to send at 5 Hertz. You're sending it 5 times a second and you want it to look good. Well, you're going to have to play around with your value blending and really figure out the best way to do with that. And by the way, that explains it. That explains it. I know, I just figured it out. Okay. This video is going to be long. It's going to be crazy. And I know that you're along for the ride and you want to learn this stuff and you want to learn it fast. Whatever. If you're sticking around and you want to actually follow through with what I'm trying to learn here, I just now figured out in my mind why it still looked like we didn't change this implementation and now all of a sudden it looks good. It's not merely because we went and changed this guy to 20 Hertz. Because if you think about, let's take a look at the calculator, and 1,000 milliseconds makes up 1 second. So we divide that by 5, that gives us 200. So that means every 200 milliseconds is when we're receiving a value. But if you recall, we set the buffer to 100 milliseconds, which means we're not going to have values. We're going to have to extrapolate again. So when I put that down to 0, it's going to be pretty much the same as 100 because we're only getting values every 200 milliseconds when we have this guy set to 5. However, if I set this to 20, now what does that mean? That means we're 1,000 divided by 20. We're getting a value every 50 milliseconds. And that works really well because we've got 100 milliseconds worth of buffer time. So we're going to have 1 or 2 values and we can properly value blend between those two. So the moral of this story is, and I'm going to prove it. I'm not just going to say that. I really want to prove it because I don't like it when things don't add up and I just have to kind of hand wave. Even though I have explained it, I want to prove it. So let's put this back down to 5, okay? So with that being at 5, this now needs to go up to over 200. So let's put it at 400. So now there's a 400 millisecond buffer. That means there's going to be a lot of baked in latency. But that's because we're going at 5 Hertz and we have to build up enough buffer. So this is actually going to cover it. Anything less than 200 won't work. It needs to be well over 200. Like 250 would probably be good, but I want it to be safe and I want to make sure we probably get at least 2 in the buffer so that we can get a good interpolation. So that's what 400 is. And we're leaving this at 5. We're going to save it. Yep, and you know, since I changed this guy right here to 400, this is in the global. I need to, and that's in the level. So both sides actually need to know about that. So I have to build it. So hopefully I am right here, and it proves why things were looking so terrible when we had the buffer at 0. It was always extrapolating, and then we had the buffer at 100. And we had the synchronization frequency to 5 times a second, and it still wasn't looking good. Now it's going to look good. So now we're going to do this. Now we're going to come back here. And in fact, what am I doing? Yeah, thank you. Sorry. Okay. So I should maximize on play, whatever. All right, so now you see there's a lot of latency in between when I do the movements. However, they are very buttery smooth. It's at 5 hertz, and I'm sorry I've had to remember this in the video, but now you've kind of walked through it. Going through that stuff helps you understand it. And that's how you get smooth. That's how you get smooth value blending. But you have to know what all those various things are that affect it. How much of a buffer lead time do you have? That all plays in. I mean, I could step through all the code and you would see what was happening and eventually maybe be able to figure it out. But now that you've watched the whole video, you have a much better idea of what's going on. And I feel pretty satisfied about that. So you could go back to this a little bit simpler implementation and it would look better than what we just saw when we first ran it, because of us playing around with this guy right here. All right, cool. Great. There you go. Let's end that. Hopefully this time will be good.